Hi guys, so we're going to start on perpendicular bisectors and circumcenters now. What a perpendicular bisector is, it's basically this line that goes through the triangle right here. In order to use the perpendicular bisector, we have to follow the perpendicular bisector theorem. The perpendicular bisector theorem states if a point lies on the perpendicular bisector of a segment, this one, then it is equidistant from the endpoints of the segment. So you can tell it is a perpendicular bisector because in order to be perpendicular, a 90-degree angle has to be formed when it cuts through that. So here it's saying line segment CD, that's this one, cuts through AB, that's this long one. So this is the perpendicular bisector part. The orange, or not orange, yellow or green that I just colored. Then that means AD has to be congruent to DB. So that means those two have to be the same. That's what this theorem is saying. Because those two things are the same, that means my two, let's call them diagonals, the two side legs of my triangle are also the same. So that means line segment AC has to be congruent to line segment BC. So because this is cutting through, my two things at the bottom are the same, but so are these diagonals too. Now, if we look at the converse, remember the converse is saying the opposite thing. It's saying the opposite thing. Sorry, brain fart. So, if the point is equidistant, that means it is a perpendicular line segment. So, because AC is congruent or equal to CB, that means line CD has to be my perpendicular bisector. So, line CD is my perpendicular bisector of segment AB. And because of that, that means AD is congruent to BD. Lots of words. It'll make more sense once we start working through the problems. So here is my first example. Oh, slide it up too far. Slid up, not slided. If I'm finding the value of x, here is my perpendicular bisector. These two segments are congruent, so that means these two segments are congruent. Because those two segments are congruent, I'm going to take them and I'm going to set them equal to each other. I like starting with my biggest variable, or my biggest coefficient with my variable on the left side. Now I'm just going to solve the equation. This is a multi-step equation, so it's going to take more than one step, more than two steps. I'm going to subtract 7x from both sides. That's going to give me 6x minus 48 is equal to 24. Now I'm going to move my constant over. When I move my constant over, I'm going to do the opposite of what I see, so that's adding 48. So that gives me 6x is equal to 72. Now to figure out what my variable is, I am dividing by my coefficient. So x is equal to 12. So now I've got to do number 2. Number 2 is the converse. So it says because these two are the same, this is my perpendicular bisector, so both of these are also the same. Same steps again, set them equal to each other. So I'm going to move my variable over. That should give me 8x. Now I'm going to move my constant over. That should give me 16. Now to figure out what x is, I'm going to divide by my coefficient. So x should be 2. If you'd like a challenge, pause the video and see if you can solve the next two. So because here is my perpendicular bisector, these two bottoms are the same, I'm setting these two sides equal to each other. 7x minus 22 is equal to 4x plus 5. Move my variable over. That gives me 3x minus 22 equals to 5. Add my constant. That gives me 3x equals 27. Then my last step is to divide by my coefficient. That gives me x is equal to 9. Then in number 4, because these two are the same, here is my right angle, because that's my perpendicular bisector, so these two are the same. Same steps again. Move my x. That gives me 2x minus 11 equals 17. Add my constant. That gives me 2x equals 28. Now my last step is to divide by my coefficient. Here is my final answer. X is equal to 14. Questions, please ask your teacher. Now we've got one more thing. When we started this, I said we were talking about perpendicular bisectors. We've covered that. We're great at that. Now we have to look at the circumcenters. So when we're looking at the circumcenters, we have a whole bunch of stuff we have to look at in order to be able to say that it is a perpendicular, in order to say that it is a circumcenter. So when you have the perpendicular bisector, here's my perpendicular bisector. I've got 3 of them. They all meet, all 3 of those meet at this point in the middle. That is called your circumcenter. So P is my circumcenter. The circumcenter is always equidistant, which means the same distance from the vertices of the triangle. We're just going to cross that a little bit out because it doesn't belong there. This is all one sentence. It just got split up. So my perpendicular bisectors, remember I said there were 3, are all of the ones with right angles. So here are my right angles. So my first one, we'll say that's segment EP. Next would be segment FP. Last, segment DP. Now, like I circled, my circumcenter is this point in the middle. So that would be called point P. So now I have to look at all my congruent segments. My congruent segments would start with AD. See how there's one little tick? So here's my first one, AD is congruent. Find your second tick to BD. Next, we'll go with the second ticks, or the 2 ticks, I should say. FA is congruent to FC. Then go with the 3. I've got BE is congruent to CE. Now we've got one more to talk about. There's no more tick marks, but a second ago, up in this definition at the top, it says the circumcenter is always equidistant from the vertices of the triangle because of the perpendicular bisectors that make it. So that means our last set that has to be perpendicular are these that I made blue. all three of these have to be equidistant, which means the same. So my last one would be AP is congruent to BP, is also congruent to CP. Kind of hard to see, I'm sorry, I wrote really big. If you've got any questions on this unit, please do not hesitate to ask.